In this video, we're going to lay the groundwork for section 3.2, which is the exponential function. I thought we would start with a way to motivate the exponential function using the concept of money. So here, if you imagine you have a person, the yellow person here, they are doing this very interesting thing, just holding a big yellow block, and they're holding a sign, and they're being paid amount of money for that. So they're being to hold the whole block, 100% of the whole block. They're being paid $1 for that, and to hold the whole block, they're being paid $1. And they're so kind of tired of this situation, and somebody comes along, the gray person here, and here's an opportunity to make some money. If somebody's tired of something and you're willing to do it, you can make some money off of that situation. So there's an agreement that they're going to strike between the two of them. The person in yellow and the gray person have decided that for something called interest, for an interest charge of 50%. So for 50% more of the block, they'll get charged 50 cents. Okay, so half of $1 is 50 cents. So the agreement is if the yellow person pays more money to the person in gray, that they will switch places. And that's exactly what happens. So what happened here, the agreement is the yellow person was originally holding the full weight of the block, which was $1. But they agreed on 100% interest. I'm sorry, 50% interest. So for an extra 50% of the block, which turned out to be 50 cents of the full amount of the block, that they will switch places. So they've agreed that they will switch places, and the yellow person is now paying the person in gray $1.50. So, the yellow person had to pay out more money, but they're no longer holding the block, and the person in gray is now excited that they're making $1.50. But the person in yellow is now happy because the person in gray didn't ask for 200% of the full weight of the block. If they had charged 200% interest, then they would have been earning at $2. $2 of the full 100%, in which case the person in gray could have made $3 because the person in yellow was really happy to be getting rid of that block. So the person in gray could have charged more, a higher interest. Okay, so this concept of interest is something kind of that free money is being made. So here we have a graphic which I'd like you to hang on to this idea. I would like you to envision that you are going to a bank, okay, and you have $1, one single dollar, okay, that you're going to give to the bank. And that's what's going to be called your initial investment, the amount of money that you have at the start. That's what A0, the initial amount of money that you're going to invest. And then when you invest your money, you no longer have it, and you've now given it to the bank, and they have to entice you to give them your money, so they're going to give you an interest rate. Okay? And the amount of money that they're going to return to you, the amount that you're going to have in the account at the end of 1 year, is the initial dollar that you gave them. The 100%, that would be right here, and the initial amount of money you gave them is right here. Okay? So 1 plus 1 times 1, this formula gives you $2 at the end of the year. That's what we are seeing here. Okay? So this is the concept of interest. You give somebody your money, and they have to return you more money at some interest rate, and your dollar became $2 at the end of the year. Okay? So that's the initial concept of interest. Okay? Now, there's a further idea here the concept of compounding of interest. Okay, same situation, you go to the bank, you give them $1, they've decided you've agreed on 100% interest, but you're now going to agree that they're going to compound interest twice, which means that they're going to give you 50% interest, but they're going to give you your 100% interest split into two. So they're going to give you 50% for half of the year, and the other half of the year they're going to give you the other 50%. Okay, so if you allow compounding, you'll have $2.25 at the end of the year instead of the $2. So compounding, okay, led you to getting more money than the $2. So here's how that computation works. Okay, and then we'll kind of speed this process up. This is the amount of money in the account after 1/2 of a year. Okay, you had your initial $1. You've had the $1, and that's what earned interest. But instead of earning 100% interest, it earns 50% interest. The 100% interest divided by the total number of compounding. So you're getting 50% interest for the first half of the year. That computation will give you $1.50. So after 1/2 of a year, you have $1.50 in your account. But you're not at the end of the year yet. Your $1.50 still can earn interest. And so you take the amount at the end of 1 year, you take your $1.50 of interest, and that is what you get your the remaining 50% interest on. So if you take $1.50 and then earn interest on that $1.50 at 50%, and do that computation, you'll get $2.25 at the end of the year. Okay? Continuing this process. Sounds pretty fun if you allow more compoundings. Okay, at the end of a year, if you can convince the bank to compound 4 times a year, you're going to get $2.44 in the bank. Okay? If you can convince somebody to give you 12 compoundings a year, okay? 12 compoundings a year, you'll have $2.61 in the bank by the end of the year. Okay? It'd be really nice if there was a formula, right, that says 365 times a year. Okay, we need to talk about where these numbers have come from. You're getting $2.71 in the bank at the end of the year. So your money just keeps going up the more you compound. Okay, does this sound like a limit problem? Probably should. Okay, so what we're seeing here's a formula that we should probably get used to using. The amount of money in the bank, at the end of 1 year, if $1 is invested, $1 is your initial investment, you're given an interest rate of 100%. Okay? And the only thing that's changing in this problem is the number of compoundings, how often interest is compounded. Okay? Here is a formula. The amount of money in the bank at the end of 1 year, if you deposit $1, is 1 plus 1 over n to the n power. So if you were allowing only 2 compoundings a year, you would have 1 plus 1/2 to the power 2, which is 1.5 squared, which turns out to be $2.25. If you allowed 12 compoundings a year, the amount of money your dollar would grow to at the end of the year would be this number. And if you compute that on your calculator, you will get whatever it comes out to be, some dollar amount. If you put, n is equal to 365. Okay. 1 plus 1 over 365 to the 365th power. You'll get the $2.71. Okay? So how much would you have after 12 compoundings? It would be 1 plus 1 divided by 12 to the 12th power. Okay? We should probably turn that to a decimal, sorry. You'll have $2.61. Okay, that must have been this number here. So it's fun to play the game. What if you allow a very large number of compoundings? 1 plus 1 divided by a really big number. How about 1,000,000,000? 1 million compoundings a year raised to the 1,000,000,000. Oops. It's a big number. Let me convert it to a decimal. Okay, let me close the parentheses. $2.71. Again, 0.8. Okay? So what we're seeing here is we're seeing a limit process happening. The limit, as the number of compoundings goes to infinity, of 1 plus 1 over n to the nth power. That actually, this limit exists, okay? And you can see that it's somewhere around $2.71 with some change, okay? $2.71 and maybe a little bit more in the 8 column, okay? That limit is what's called the number e, e to the first power. E to the first power is the amount of money that you have in an account that earns interest if $1 has been invested, okay, and you can convince somebody to give you an interest rate of 100%, and if you could further have somebody agree to compound it a very large number of times. The maximum amount that your money can grow to, the maximum amount $1 can grow to, is about $2.71 with a little bit more after it, otherwise known as the dollar amount E. Okay? So, here's where we've talked about what happens as n gets really big. We're seeing that the larger and larger the values get, the values aren't getting bigger than 2.718 with some more change. Okay, so the value keeps going up and up, but it does level out. And here's what I wrote just a second ago. The limit, this limit, is the number e, and here's its decimal to 5 decimal places. That's approximately what that limit is. Okay? So now that you know what the number e is, it's about how much a dollar can grow to in a year at 100% interest, you can now start to play the game. Right? What if you change the interest rate? Or what if you change the amount of time that the money can grow for? Okay? So this leads us to the idea, what is e to the x? E to the x will be the limit as n goes to infinity, 1 plus 1 over n to the n multiplied by x. Okay? And the way to say this is what it is the amount of money $1 can grow to, $1 initial investment grows to after X number of years if the interest rate is 100%. Okay? And that's what we can see over here. If you have $1 to invest, and you can invest that money for a long amount of time, exp to the 1 is how much money a dollar will grow to after 1 year, $2.71 with some change, 828. If you can allow that money to grow for 2 years, $1 grows to grows to this amount, e to the 2, after 2 years. Okay, you'll have $7.38 with some more change. If you allow the money, a dollar, to grow at 100% interest for 3 years, you'll have the amount of money $1 grows to after 3 years, $20. Okay, that is the meaning of the exponential function. Okay, e to the x. E to any number x, exp of x, is how much money you'll have in the bank if you let a dollar grow for 1 year at 100% interest. So if the amount of time, if you plot this for say 0 to 5 years, here is a plot of your exponential function. If you can let your money $1 grow for 5 years, you're going to have around $150. Okay, so let's check that out. EXP of 5. E to the 5 is what it's shown as. If I convert that to a decimal, you'll have $148 in the bank. $1 will grow to that. So that is the meaning of the exponential function, and it's going to be the follow-up video to talk about how to take the derivative of that function.